Let's go on into the part 2 of the reading the structure. Reading the soil test report. So in this video, we'll be actually talking about why you should never go beyond the recommended foundation depth of your soil engineer or your structural engineer. Let's start. Okay, in the previous video, I think I've explained what the society's bore log and what they actually are. So this is another type of bore log that we'll be using for the example here. So here we can see the type of boring here. In the previous one, the type of boring they used shell, but here they used rotary drilling, and the groundwater table is 1 meter below the ground level. So you know what that means? It means that you have to prepare to dewater the sites when getting to that depth. So let's go to the recommendation before we come back to what we say. Okay, let me explain. This is the end value. We know what it means. So the higher the end value, the better the soil. So that is more of what it means. So this is the description of the soil strata. Here at thickness layer at 0 from the ground floor level to 1.5 meter, we have black sand. From 1.5 to 2.5, that is, we have another 1 meter thickness of clay sand. Then we have another 2 meter thickness of white sand. Then we have another 3.2 meter thickness of sand. Another 4.25 meter thickness of clay sand. The next depth. Okay, this is depth. This is level 0 to this place. This is level 1.5 meter. This is level 2.5, 4.5, 7.7, 11.95, and so this is okay. We talked about the depth already. Then this is I don't know, whatever the standard penetration test, whatever that one is. Then the end value, we have 3 at this place. We have another 3 in the next layer. Then we have 23 again at the next layer. And we have 24. So what this means is that the deeper the size of the deeper you go, the better the soil. Well, however, when we get back to 7 meter, our soil becomes another poor soil again. It starts to reduce. The end value starts to reduce again to 3 meter. I said 3 meter. 3 to 2. So which is 4. And it has already given us a sign there. So let's move on. The recommendation for the foundation is 2.5 meter depth with bearing capacity of 150 kilometers per meter square. That is from the geotechnical engineer. So the structural engineer will use this to design his footing, and then recommend that in his drawing is going to show that the footing should be found at 2.5 meter below the ground level. Alright, so when the site engineer wants to start, you must not go beyond this 2.5 meter. Reason is because, let's assume you have designed for let's say you've designed for 2 meter by 2 meter pad base here at 2.5 meter. So this is the level, this place where I'm posting my cursor. This is where you are supposed to dig your foundation on site. Now, let's say you did the right thing, 2 meter by 2 meter. So, and the back base is sitting on this level. So the pressure bowl of your foundation of your pad fitting is going to fail. It's going to react up to 2 times B, that is 2B. 2 times B is the width of your pad fitting. So 2 times, let's say your this thing is 2 meter by 2 meter. So your foundation depth is your pad foundation size is 2 meter by 2 meter, and it's sitting at 2.5 meter below the ground floor level. But it's still going to be exerting pressure to a certain depth beyond that 2.5, and that depth can be calculated or estimated as 2.2 times B. So it will be, let's say 2 times B is 2 times 2. So it is going to be, that's 2 times 2 is equal to 4. So this is from here to here is 2 meter. So from here to here, the 4 meter will be somewhere here. So you might not have any problem because the end value here is still greater than this, which is 50. So do you understand? If you don't understand, you can chat me up on the Telegram channel or on our WhatsApp group. All right. So now let me explain better now. So now let's assume that your your site engineer wants to be safer. Instead of him to now dig up to 2.5, he now dig up to 3 meter. So because he's scared that 2.5 that 2.5 depth is too small, that he wants to be safer, he's not be dug up to 3 meter to be extra safe. Meanwhile, he's not saving, he's exposing the project to instability or to more danger. So let's say you now the site engineer dug up to this 3 meter depth. So and we have 2 by 2 meter by 2 meter pad base. So if the foundation depth, if the pad base is sitting at this 3 meter depth, the force, the pressure will still be exerted at 2 times B. So which is 2B. 2 times 2, which is 4. So now calculate 4 meter. 4 plus 3 meter is 7 meter. 7. Okay, it's still safe. It's still safe because the 7 meter is still around this place. So now let's say it's becoming safer. you now dug up to 4.5 meter. So you already know what that means. So or maybe even gone, let's say he just dug up to 3 meter. It didn't go beyond 3 meter. Instead of 2.5 meter that his son engineer asked him to dig, he dug up to 3 meter. Then maybe the structural engineer also, he didn't pay attention to this ball lock. Now maybe the pad base is 3 meter by 3 meter. So calculate 2 times 3, that's 6. So let's say from this 3 meter, the pad base is sitting at 3 meter. You know, the structural engineer has made a mistake. The site engineer has already made a mistake again. Sometimes in some soil test reports, the geotechnical engineer, they used to tell you that your pad base must not be bigger than, they will give you the size because of this thing, because of this type of situation. So they can tell you that your pad footing should not exceed 2 meter by 2 meter, and it must be found at maybe 2.5 below this ground floor level. So if you didn't pay attention to that, maybe your pad fitting is now 3 meter by 3 meter, and even let's say your site engineer didn't make any mistake, he placed his footing at this 2.5 meter, but your foundation is 3 meter by 3 meter. So 3 times 2, that is 2B. The pressure will still be exerted at, from here, 2 times 3 is 6. So 6 plus 2.5 is what? That's about 8.5. So your pressure, the pressure bowl will still be exerted up to this point. So which may cause settlements because the density of the soil is not much. It's very loose. So it can exert pressure on it, and it's going to be causing settlements for the structure. And when the settlement is beyond the permissible from the soil test, so you can be having cracks in your building, and which will cause some sort of instability in your structure. So that is that. But we must also always pay attention to this. So when we get a soil that is unstable as this, so what we need to do is that we should make our structural layout more robust so that it won't require a larger size of part base. So that is what it means. So let me explain better with a diagram. So this is what I mean by pressure ball. If your part footing is sitting at this level, the pressure from the column that part footing is supporting will still be, the soil will still be exerted up to 2 times B of the part footing. This is B. The B is the size of your part footing. So multiply by 2. From here to here is 2B. So this place will still be feeling that pressure. And when the soil is soft, from maybe the soil environment is softer at some point, you might have a little bit problem that we might have. What's it called? I mentioned it earlier. When the soil is easily compressed, we might have settlement. So that is what it means. So I think with that, I've been able to explain why it should not go beyond what it is recommended for your soil report, and the soil report for your foundation depth. So when the structural engineer say your foundation should be founded at 2 meters below the ground floor level, you should do so on site. You shouldn't go beyond, and you shouldn't go above it. So that is what it meant. So thank you for listening.